Good morning, all of you. Okay, in this class, I am going to explain most important topic for you. That is Kepler's laws, like Newton's laws of motion. Newton gave three laws related to motion, same that Kepler gave three laws related to planetary motion. Okay? How planets are revolve around the sun. Okay? Here, first law, each planet revolves around the sun in an elliptical orbit with the sun at one of the two foci of the ellipse. Look here, this is an elliptical orbit on which any planets or Earth revolves around the sun. It has two axes. First one is called major axis and other is called minor axis. Okay? It has two focus. Suppose first one is located here, and if sun is located here, then the motion of the planet is first nearer part of the sun. Okay? And further or far away distant part of the sun, its motion is slow. It appears, but it is not actual. Okay? Suppose in time t second, the planet starts for moving at point C and reach at point D, and again in the distant part of the sun, it starts from A and reached to B. According to the second law, that means law of aerial velocity. Okay? Area of triangle CSD always equal to area triangle ASB, that means CSD. Okay, this area is always equal to this area, that means ASB. Okay, this concept is based on the body falling from some height. Okay, if body is far away from the surface of the earth, then it appears dropping slowly, but when it comes nearer part of the earth, then it appears moving fast. Okay, but it is not actual. Okay? That means according to the second law of the Kepler, the straight line joining the sun and the planet sweeps out equal areas in equal time intervals. Okay? Therefore, aerial velocity remains constant. That implies area triangle CSD always equal to area triangle ASB. This is the Kepler's second law of planetary motion. It is also known as law of aerial velocity, while first law is also known as law of orbit. Okay? According to the third law of Kepler, okay, third law is also known as law of period. Law of period. Okay, that implies the square of the orbital period of the planet is proportional to the cube of mean distance of the sun. Okay, cube of the mean distance of the sun. That implies according to the law of period, okay, t square variances are cube. Okay, where t is the time period and r is the mean distance of the planet and the sun. Okay, that implies t varies as k into r cube, where k is a constant. Okay, k is a constant. It can be also written as, do you know what is the time period? The time taken by the moving body to complete one rotation is called its time period. Okay, time period, the time taken by the moving body to complete one rotation or oscillations is known as its time period. Here t is equal to k into r cube. That implies t square upon r cube is equal to k. This is the equation 1, and it is known as law of period. That means Kepler's third law of planetary motion. Okay, equation 1 is also written as, equation 1 is also written as t1 square upon r1 cube is equal to t2 square upon r2 cube. Okay, this is the another form of Kepler's third law of the planetary motion. Okay, on the basis of third law of the planetary motion, Newton guessed inverse square law. That means on the basis of this law, Newton obtained inverse square law. How Newton obtained? Look here, I explain it. Okay, planet is commonly moving on the elliptical orbit. Approx it is in the form of circle. Okay, hence definitely a centripetal force is acting on it. Okay, centripetal force is acting on it. Newton's conclusion of law of period from law of period. Newton's conclusion from law of period. Okay, if v be the velocity of the planet on the orbit around the sun, hence a centripetal force is acting on it. A centripetal force is acting on it. Definitely a centripetal force is acting. That implies F is equal to mv square upon r, where m is equal to mass of the planet, v is equal to velocity, r is equal to radius of the orbit. Okay. Okay, F is equal to mv square upon r, where m is the mass, v is the velocity, r is equal to radius. From Kepler's third law, T square is equal to K into R cube. Okay. And the distance covered is equal to 2 pi r. That means the circumference of the orbit in one rotation. Here t is equal to time period. Therefore, velocity is equal to 2 pi r upon t. Okay, that implies v is equal to 2 pi r upon t. Putting the value of v in 1. Okay, from 1 we have, okay, according to equation 1, F is equal to m into 2 pi r by T whole square upon R. Okay? That implies F is equal to M into F is equal to M into 4 pi square R square upon T square into R. Okay? That implies it will become F is equal to M into 4 pi square R upon T square. But from third law of planetary motion, T square will be equal to K into R cube. That implies in place of T square we put the value here. Okay, that implies F is equal to M into 4 pi square R upon K into R cube. Okay, here F is equal to M into 4 pi square R upon K into R cube. It will become R square. This equation is also written as M into 4 pi square upon K into 1 by R square. Okay? But M into 4 pi square upon K is a constant. Okay? Therefore, F is equal to constant into 1 by R square. Equal to and constant. This will indicates that F varies as 1 by R square, and hence Newton obtained inverse square law.